Good evening and a warm welcome to all. Welcome to our session 5 series of webinar on mathematics. Our today's topic is maths through the lens of misconception. The specific topics are place value, counting, addition, and subtraction. Mathematics is always perceived as a tough subject by many of the students, and so many of the students also suffer from phobia of mathematics. So we have a resource person, Ms Sangeetha Saranathan, who will be talking about ways and means of mathematics, very interesting to the kids. Ms Sangeetha is a multifaceted personality, educator, entrepreneur, and a teacher trainer. She's a graduate of IIM Indore, and she has always had a keen interest in understanding how children learn and apply interrelated concepts using activities, kinesthetic materials, and visual stimulation. In the course of her career, she conducted many workshops for teachers in Indian schools across CBSE, ICSE, and other boards to help them incorporate some of the best practices across the world in their classroom teaching. She has worked extensively in developing diagnostic assessment tools in maths. Adaptively built diagnostic assessments help parents and teachers understand how to incorporate personalized learning plans for each child within each classroom. Ms. Sangeetha has also presented many papers at conferences at IITs on how to help a K-10 system to be more math learning friendly rather than math memorizing friendly. So we are going to have a very interesting session with a very eminent person. And wish you all a very happy and active listening for the session. I request our RP, Ms. Sangeetha, to take over the session. Thank you.
Thank you for that introduction, and welcome to everybody. Good evening. Special welcome to all the educators, teachers, and I think homeschoolers, because COVID-19 seems to have forced many parents, willingly or unwillingly, to take over the mantle of homeschooling. So welcome to all of you. And I'm sure all of us make a wholehearted, very good effort, in making math interesting. And we also want our children to master mathematics without any errors. But a teacher or an educator with a lot of experience, especially, would have seen that their children tend to commit errors regardless of how well intentioned our approach towards teaching them is. And you will also see with experience that children tend to commit certain types of errors repetitively year after year. So in today's session, we're going to be looking at what are these common kind of misconceptions and errors, and what kind of teaching strategies can we employ to address these errors, to ensure that they don't form in the first place, ideally. But if you happen to have children who've already had carry these misconceptions in their head, then this is something you could adopt to ensure that it gets remediated over a period of time. So let's get started. And I'm going to start today's session with a short story. This is a story about a teacher who's a pottery teacher. So he teaches children how to make pots with clay. And the teacher teaches them, basically how to use clay, put it on the pottery wheel, and then a lot of children start making pots with them. Now, after about a week or 10 days of teaching them the basics of how to make a pot, the teacher divides the entire class into two groups. And he gives the first group a task. They have 2 weeks' time in which they have to make one perfect pot. It has to look fabulous and it has to be perfect. And he tells them that at the end of the 2 weeks, they are all going to be graded based on how fantastic that one perfect pot is. And then there's a second group, and to this group, he gives each child 10 kilograms of clay. And he says, for you, you have to make as many pots as you can with all the clay that I've given you. You're going to be graded based on the number of pots that you make. And at the end of the 2 weeks, we're also going to host a competition where we will take one pot of each child from the first group. And from the second group, again, each child can choose one pot out of all the pots that they carried. and that they made, and then they can enter that into the contest. So the end of the 2 weeks, what happened was that when they had a competition, the top 3 pots all came from the second group. Not even one pot came from the first group. And I have a question. If I may invite the participants, if you could just key in your answers, on the chat box that you're using. Why do you think this happened? Why do you think everything came only from the second group? Why do you think nothing came from the first group of children who were focused on making that one perfect pot? And if you can think of a takeaway of what does this have, what bearing does this have to children learning mathematics? Technically, what bearing does this have for any child learning any subject, in fact? So if you could just type in your answers and wait for a minute. I'd like to see if any of you have any interesting insights towards this.
So the answer here is team efforts work best.
Okay.
I'm looking for answers. Courtesy the lag in the Facebook, we'll be getting the answers a little slower.
Sure.
However, the first answer that we'd be getting is from the Zoom chat. So the first answer is team effort works best. Coordination is the second answer.
Okay.
Practice makes them creative is from Facebook. We are getting answers from Facebook.
Great. Almost all of them sound pretty much along the lines.
Practice leads them to perfection, collaboration.
Yeah.
Then there is one answer from Ms. Anita on Zoom. Maybe they did not understand what should be shown.
Okay, great. Thank you. I think pretty much all of you were, you kind of almost hit the nail on the head. But to sum it, there were 2 important takeaways. Number one is that for a child who's trying to learn anything, if they are trying to accomplish that, whether it is solving an addition problem or solving an algebraic linear equation, it doesn't matter. Whatever it is that you're trying, if your aim and hope is with the best amount of planning that I will come with that one perfect solution, versus I will try many different methods and approaches in solving many different problems. And during the course of my doing this, I will come across many errors and misconceptions of how to solve this problem. I'll have to overcome each one of these and only then get the right answer. So, for a child, the first key takeaway is that, for all of us to also understand from the viewpoint of a child, is that errors and misconceptions in learning anything is an inherent and an imperative, perhaps, for you to get closer to the most perfect solution. So if we target, so which brings us to the second part, which is what is the takeaway for a teacher? If you attempt to teach somebody using a single strategy, which is to make that one perfect solution, we probably won't help children. Helping them through multiple different strategies and approaches, even if it is just one concept. You may be teaching them just subtraction, just taking away 2 from 8. That is all that you're doing. But teaching that through multiple different methods, it could be visual stimulation, it could incorporate music, it could be multiple different methods. Like the children who made many, many, many different pots, usually approaching to solve one problem with many strategies helps children understand and overcome multiple different errors and misconceptions also that are inherent in learning any concept. So with that underway, let's move on to seeing what we're going to be looking at in today's session. So today we're going to mainly focus on the primary years of learning. So we'll begin with a child's basic understanding of counting, the place value of our decimal number system, base 10, addition and subtraction, and we'll jump in there. So if you're talking about just counting from 0 to 9, to all of us, it looks extremely simple, right? But if you think about a child who is 2 or 3 years old, who's being exposed to the idea that a quantity can be attached to a number, which has a certain symbolic representation, it's not really that simple. So there are 5 different misconceptions that are commonly attached to very, very young children when they're learning counting. These are technical terms, so don't worry. You can read the simple English explanation within the parenthesis. That should make it simpler. And this PPT, I'm sure, will be available as a video, so you can take a look at it later. So we look at the first one, and I invite responses from all the teachers and people who are listening. I have a question at the end of this. So the activity here is you can take beads or pebbles or stones to do this activity, any small thing, or plastic chips or counters that if you have, you could use something that is a little bit tiny to do this activity, where you first expose the child by placing all that you see. If you have a set of 9 of these, you put them like this in an order, and then you ask the child to count. Then you take the same things and arrange them like, in the second way that you see it arranged in rows of 3. And you ask the child to count. And then you go ahead and you arrange them in the fashion that is mentioned below. And now you ask the child to count. In each time the child will get the same answer. The total number is still only 9. My question to you is, why do you think we need to arrange the same number of pebbles or stones, the activity that you're doing? Why should you do it in 3 different ways? What misconception are we avoiding in the mind of the child by doing this activity? If you could just type in your answers in the chat box, that would be nice.
So looking for answers.
Yeah. Why are we placing counters, in 3 different ways? For the same number 9, we're teaching them 9. Why should we place them like this, and then like this, and then, all over the place?
Just waiting for the answers to come.
Yeah.
To develop number sense. That's the first answer.
Yeah.
To avoid linear addition only.
Very correct. Yes.
That there are a lot of methods for any problem.
That is quite true. Okay, wonderful. I think, yeah,
yes.
Sure. Go ahead.
There's 2 more answers that we are getting, a lot of answers rather on Facebook. So, oh my goodness, okay. Counting concept should be clear for children, perception skill.
Okay, very right.
And creativity varies.
Absolutely.
To set different patterns are possible.
Quite right.
Age-specific method.
Appropriate, yes. Okay, wonderful. I think almost all of you were kind of right. So if I may just summarize or rephrase what you've just said. Number 1, when you're counting something, we tend to usually show them, arranging them in a certain fashion. And the misconception that a child might get is that all objects that are counted have to be placed in that linear fashion, one after the other. That is not true, because you're trying to tell them that it is a sense of quantity. So even if it is scattered all over the room, if I have a bunch of 5 basketballs and if they are stacked one on top of the other, that is not the only way 5 works. 5 balls can be all over a basketball ground. 5 balls can be all over my, all over a table. So 5 can be even scattered, like we see in the third example. 5 can be placed next to each other also. That's one. The second misconception that we are helping a child avoid, and which comes with a lot of practice, this is a kinesthetic activity, so it definitely involves the touch and feel of whatever object we are giving the child. They have to learn that once you've counted 1, so you have to move the object that has been counted away, and then you move on to the next. When you're looking at the arrangement in the third fashion, you will be forcing the child to move the counted object to one side and then move to the other object. So you do not count the same thing many times over. And teachers may have seen that children make this mistake, because unless we make the effort of putting the right strategy of arranging things differently and forcing them to do it under different patterns, That is the only way we'll help them avoid this misconception. So here I just want to quickly point out, if you happen to be teaching online. Now, some of the strategies we're talking about are, yes, fantastic. They work in a classroom setting. What do I do if I'm teaching live online like this, which today's pandemic has forced some of us to do? I think do two things. One is, if you can, as far as possible, if you're working with children who are under 5 or 6 years of age, using materials and objects around them, touching and feeling is very, very, very critical. So if you can plan in advance for this kind of a session a week in advance, you can just send out an email or whatever, keep the parents informed to let the child pick up some leaves in the neighborhood. Children would usually love to go around and collect all these leaves, and you can ask them to have pebbles or whatever is available in their house, and keep these ready, and tell parents to keep objects of count up to 9. You can even ask, if none of this is available, just ask the parent for a cup of rajma or a cup of chana dal. These things are usually always available in houses. So ask the parents to give the child these objects, and then tell the child to arrange them. Show them the picture of something like this on a PPT when you're teaching. Then you change the arrangement, and then you change it in a scattered format, and then ask the child to do it in a live online session. And I have seen very often a common question is, children don't like to listen to me, when I'm teaching. How do I keep them engaged? As it is, when you're teaching children, in person, in a classroom, it's hard enough to keep their attention. Live online is even tougher. But live online is very, very good, because you can give every child an object with the respective household can just contribute. And if they're doing something while you're teaching, you are definitely ensuring that they are paying attention to what you're saying. So whether it's a brick and mortar setup, or it is an online virtual setup, you can still work. If you're not able to get objects, what can you do? If you're using something like this, a virtual screen board, you can draw these things. Like, let me just sort of show you. You could just draw these things like tiny little circles over here, and then you can just ask the child to count how many circles have I drawn on this screen. And now we go on to the second form, the second teaching strategy, when we are talking about what's you can use objects. I will go on to what misconception we are helping a child avoid. You can ask the child to pick up a bunch of household vegetables, fruits, whatever it is that they have. If you're doing this in a classroom setting, you could even use chalk pieces from your chalk box. You could use crayons. You could use sketch pens or color pencils. I just picked up, and it's the mango season. So if you're doing live online, you can just ask children to get a bunch of mangoes from their home. So here, the activity is, you need to tell the child to count. You will give the child a number and tell them, why don't you pick up 2 mangoes? And when they pick it up, they need to say the number aloud, to say 1 and then 2. And then if you have, or if you're using, say, something like ice cream sticks, and if you tell them, why don't you pick up 5 ice cream sticks? They've got to say aloud, 1, 2, 3, 4, and 5. And they've got to do it slowly and loudly with you. Now, can someone tell me what misconception we are trying to avoid when you force all of these children to say the numbers loudly? When you're holding these, you've got to tell them 1, and then 2, and then 3. If you could just type in your answers in the chat box, it would be nice.
So looking for answers again.
Sure.
Okay, students can't think and answer themselves for an answer themselves. I think that is what Tariq reckons.
Okay.
Then rote memorizing. I think on Facebook, it is rote memorizing.
Okay.
That's an answer. One-to-one concept is another answer on Facebook. Missing the number count, avoiding missing count of numbers. So
correct. That's correct. Avoiding missing count is the key point over here. When you're forcing them to say it aloud, 1, 2, 3, 4. Now, suppose the child comes, the child is actually holding only 4 ice cream sticks in their hands. Okay, but you ask the child how many are there. if the child were to say 5, you are not very sure because on account of which misconception the child is saying 5. So when you force the child to say that aloud, 1, and maybe the child says 2, and then 4, and then 5, you realize the child has missed a count. So they've got to know that a count has to go only in a certain order. So missing a number or changing the order, you can't say 1, 2, 5, and 4, for instance, right? You can't change the order of numbers. So the count, while counting, the sequence and the order matter a lot, and you can't miss any numbers. That is the misconception we will avoid when you force children to touch, hold, and say those numbers aloud. Again, you could just ask children to pick up whatever household objects they have around them. If you're doing this in an online session, if you're doing it inside your classroom, you could just pick up whatever. Again, you could even choose pens or notebooks from their bag when they have to show the number of things, because it might be a little difficult for you to go around handing out 20 carrots or 20 mangoes to each child. So moving on to the next, here's the third misconception that we're trying to avoid when we're teaching them counting. Over here, this activity is very fun. It's fun for young children, and it has an element of art. So their ability to focus and do it regardless of whether you're doing it brick and mortar or online is quite high. So pick up a piece of paper, ask each child, and then come with their crayon sets or sketch pens or color pencils, and then you tell them, now draw these. I'm going to give you this free space. Why don't you pick up any 3 colors and draw them, or color them in these rectangular boxes? Or you could say, why don't you pick up any 7 colors and paint or color these 7 boxes? And the children will have to start and slowly go through the whole coloring idea. This again is a very, very good activity if you want to engage them and keep the kids focused in an online session, a virtual medium. And at the end of it, again, here the child again will need to count how many colors they've used. So they count again aloud with you: 1, 2, 3, 4, 5, 6, 7. If it's 7 colors, there are 2 important points here. The misconception that we're trying to avoid here is that the child is counting 1, 2, 3, 4, 5, 6. So I have said 6 different digits, 6 different numbers over here. But which number represents the quantity is sometimes not very clear to a child. So the highest number, the last number that you finished, that is the number which represents the quantity. So when they're counting, when they are coloring rectangular boxes going from left to right, and they're also saying aloud 1, 2, 3, 4, 5. And then when they say the last number with a high tone, 5, then you're driving emphasis to the fact that the total number that you're talking about is always the last number that you counted. So that's what represents the quantity we are talking about. And of course, because this is a kinesthetic activity where they're visually seeing and they're feeling, the ability of the child to retain this learning is very, very high. And here you could use blocks. Identically sized blocks is the most ideal. So if you're using it in a classroom setting, you get these small blocks, which could be like a Lego toy, but not exactly. You get these wooden blocks. Ideally, use that. If you're teaching online, it's hard for you to ask a child to go around finding identically sized pebbles or stones. So ideally, just draw it on a virtual whiteboard like what we have. So here, you ask a child to count the number. So you've drawn one with just 1 block, and then let's see. This one has got 2 blocks, and then you go on to the next, which has 3 blocks, 4. So far we've done counting by just counting the number of objects. But here we help them understand that if you're looking at something that is just 2, and if you're looking at something that is 10, there is a size difference. There is a difference in magnitude. So This helps them understand the concept about which number is really big, which number is small. So the principle of magnitude. So when they're just coloring, that magnitude is not necessarily in their head. But when they're seeing blocks of different sizes placed next to each other, they're able to compare the magnitudes and understand which is much bigger and which is smaller. So counting has a magnitude difference also. I mean, counting implies that if you count higher, there's a difference in magnitude, is something that stays in their heads. Here is an activity that you can do. It's a little easier to execute in a classroom setting. So you can just take sheets with some sheets with 2 dots drawn, some sheets with 3, 4, 5 dots. So you have sheets with multiple different dots drawn, and you ask a child to blindly pick up any 4, and then they've got to arrange them in sequence. Here, of course, we're going into arranging in descending and ascending order. Why are we doing this? Again, this is a visual stimulus. You're seeing more dots on one paper, you're seeing fewer dots on another paper. With visual stimulus, it helps a child to understand the concept of arranging objects in ascending order, even when some numbers are missing. So if you see, there's 1 and then there's 3 and then there is 6. So we're not going in the perfectly sequential manner, that without skipping. We are skipping some numbers. That's why we're telling a child to just blindly pick any 4 numbers, any 4 pieces of paper. So, and when you're doing this, the child understands what it means visually without ever writing a single symbol so far. So if you've seen so far in all the activities we've done, we have only used 3 things. We've used auditory. The child is listening to an instruction, or the child is saying something so they can hear it. There's visual, or there is doing. There's the principle of touch. At no point yet have we introduced the symbols 1, 2, 3, 4. We're not asking a child to look at a number and do something. It's all this hearing right now. So when you just do these 5 steps, the concept of counting, what 0 means, what the number 2 means, is very clear in their heads. So these 5 teaching strategies, more often than not, you won't see children committing errors with respect to counting. I've got 2 more activities for you, and I'd like to invite your comments. Number 1 is, if you're doing live online, this works beautifully. Even in a classroom setting, it works beautifully. You can start saying, why don't we all count 3 times, and together, with the class, you go 1, 2, 3. Or you could tell all of you, stand up. Why don't we all now jump up 5 times? 1, 2, 3, 4, 5. Why do you think we're doing this? Why is this teaching strategy different from all the other strategies we've seen so far to help young children learn?
Waiting for answers. So the child gets more involved.
Absolutely.
Kinesthetic is another answer.
Yeah.
Then on Facebook, to drive their attention is an answer from Ms. Anita on Zoom.
Absolutely. Very correct.
And on Facebook, they say playful. It allows students to do it in a playway method.
True.
Learning by doing, then mental presence is always there.
Yeah.
And oh my goodness, there's a rain of answers on Facebook. So Snappy Sounds is good involvement.
Okay, yeah, very true.
To ensure students are actively participating.
We'll take 2 more answers. Let's see.
Yeah, okay. 2 more answers. I'll take one from Facebook and the other from Zoom. So children will not be afraid of maths if taught in this way.
Very
And the next one is children are excited and involved and learn to count properly on Facebook. That's the second answer.
true. All these answers are perfect. They are bang on. Imagine even if you have to sit in front of somebody, whether it's online or not, and you have to sit in one place, and imagine a 3-year-old who has to do it. Yes, certainly you're getting the child to be more involved. It's playful, fun, all that. There's one more aspect to it. If you see, all that we've done so far has involved counting an object that you can see or touch. This is the first time we are telling even sounds can be counted. even an action can be counted. So you're moving from something that is concrete to something that is abstract. Saying even I can even count the number of songs I sing, the number of rhymes I know, the number of lines. If I were to start, if everybody were to start singing "Twinkle Twinkle Little Star," that's line one. "How I Wonder What You Are," that's line two. So it's got two lines now. So you're moving from the concrete to the abstract in a very fun and playful way, of course. So that's a very important concept that you're driving home for the child. It's not just carrots and mangoes, it's even clapping can be counted at the same time. Okay, now we're moving on to another very important and interesting concept. Again, I invite here, I definitely would like all of you to take a look. 30 seconds. The activity is very simple. Okay, on this is what you're going to be doing in your class. So on the left side, you've got a piece of paper, you've drawn 5 dots. On the right side, again, you've got a piece of paper, you've drawn 6 dots. And you've given the child some counters or pebbles or stones or whatever it is. And they've got to put that number of pebbles on their table, looking at that paper. And on the right side again, there's another child who's looked at the paper with 6 dots, and that child has taken some apples and has arranged those 6 apples. There is a difference between the child who has done the 5 dots to 5 chips, the plastic chips, to the 6 black dots to the 6 apples. What is going on here? What concept are we trying to teach the child? And what is the difference between these two children, the way they have looked at it? If you're a teacher, you've done this activity. What concept has one child understood very well, and what concept is another child not very clear?
So the answers here are eye-hand coordination. Someone on Facebook writes visual and spatial development.
Very right.
And the next answer here on Zoom is this enhances social, emotional, and cognitive activities.
Yeah.
Yes.
Okay.
Concrete to abstract. Okay.
Yeah.
Pattern method. I'm just looking for concrete answers there. Someone says more or less.
Okay.
Eye and hand coordination.
Yes, that's true. Very true.
And someone also reiterates teamwork. And someone writes psychomotor activities.
Very correct. In fact, all of your inputs are absolutely bang on. It does improve a child's hand-eye coordination, improves their visual spatial reasoning. The concept that we are trying to help a child understand is what is equal. What does equality mean, right? I'll just jump in and sort of give you one additional small piece. There is one concept that a child on the right who has understood it better than the child here. So if you look at this arrangement of apples versus the arrangement of the chips, the blue color plastic chips. The arrangement of the blue color plastic chips is the exact same arrangement of the 5 dots on the paper. This child has understood that equality represents that I use the same 5 chips or dots positioned in the same place. So the spatial distancing also has to be the same. That's when 5 is equal to 5. Whereas the child who's arranged the apples has understood something a little different. He has said that I put 6. So as long as the number 6 is same, it's fine. I can arrange the apples in any fashion. So equality is not about, when we're talking about numerical equality is not just keeping those 6 apples exactly the same way. I can put 6 apples anywhere. I can put 6 apples in a basket, one on top of each other also. It is still 6. Whereas the misconception that the child who might, the child who's done the paper, the plastic chip, blue color one, that child might be carrying the misconception that the spatial positioning also matters if you're talking about 5. So if you see a child who has only arranged, so you do this repetitively, many times over, this kinesthetic activity, But if you see that a child, every time you give them say 4 dots or 10 dots or 9 dots or 8 dots, they do it exactly the same way. Then you need to start nudging the child towards why don't you arrange it differently? Then the child must say, ma'am, but that's not equal. And that's when you've got to jump in to say, equality is not about just placing those the same way. As long as the number is the same, it doesn't matter whether they are in the same place or not. So that's a very important concept of equality, because sometime after we do the place values, they're going to jump into teaching them addition. So they have to write 2 plus 3 equal. So what does the sign equal mean? That concept of equality is what we are helping children understand right now. So this is the next big jump that they are making, the one-to-one principle of numerosity. It has to be one-to-one, but it doesn't have to be the same location. This is another interesting activity that you can do with children. This is a little easier to implement in a classroom setting than online, where you could just ask a bunch of children in your class to sit, maybe 2 or 3. And then let's say you ask 2 children in your class to sit on 2 chairs, and you come with say 8 cups. And you call a third child and you say, I want you to give these 8 cups to these 2 friends of yours, and it has to be equal. What this child has and what that child has to be equal. So the child will slowly start giving one paper cup after another paper cup, and then visually see, oh, there are 1, 2, 3, 4, and there is 1, 2, 3, 4 in the hands of both the children. So again, we are driving the concept of equality. This is a great activity. It's a lot of fun in a classroom setting. One child said, ma'am, she hasn't yet given me a paper cup, ma'am. And there's a lot of involvement in this activity. There's movement, there is seeing, there is hand-eye coordination. They are checking visually if are both sets, both the children, they have the exact same number of the object. It's a little harder to execute this on an online medium. In your classroom, this is a very fun activity where they have to understand the concept of again equality. I mean, yes, it is sort of a precursor to even equal grouping and division, but that's not what I'm trying to, what we're trying to drive here. We're trying to get children to understand that 2 things are equal first. Only when they know what 2 things are equal will they even know that what equal grouping means. So this has to be the first step towards that. Now comes the idea of visualizing comparisons. I've got a question for all of you at the end of the slide, and I'd invite all of your comments on chat. When you start getting children to again compare which number is bigger compared to another number, you could use your the abacus or any other system of arranging beads, or even if you just have a set of sketch pens, or let's say you just have a bundle of straws, you just arrange them and you put say 6 straws and 2 straws, 4 and 3, and you ask the child which is bigger. So there's a visual appeal to the child when you're doing something like this. But my question to you is, why are we, what is the difference that you see between the first arrangement and the second arrangement? And which one do you think we should be doing first? When you're introducing the concept of comparing numbers, which is bigger, which is smaller, between these two, which of this is better for you to learn?
Someone says the first one. Vidya says it's the first one.
Can you also just explain why?
Please, Vidya, because it has lesser number of colors.
Okay, so lesson number, that's a very interesting point. I didn't even notice that. Yeah, you're probably right about that.
So looking for more answers. Okay, and it is easier for the child, and because it is beautifully arranged.
Okay, yeah, that's true. It is beautiful.
The aesthetic value also counts, perhaps.
Okay.
Then Tariq says patterns, recognition.
Okay.
Most people on Facebook reckon it's the first one, so there's a lot of agreement in Facebook.
Yeah, the first one is correct.
The comparison is easy is the reason. So the reasoning is comparing numbers is easy in the first one. So
very true.
Quite similar answers there.
Yeah.
And I think, yes, Tariq, Ms. Anita says first one because there is a huge difference. difference is more.
Very bang on. So yes, that is the reason that came to my head. But I must agree that some of the other reasons that have been given are also quite appropriate, because if you have fewer colors that don't clutter the child's mind, you're not complicating, increasing the complexity. That's also a very valid point, actually. I should give you full credit. That's also very correct.
Do you want to take another one answer?
Yeah, sure. Why not?
Okay, first one, because there is a huge difference, and because it helps. One second, it's just jumped. I'm sorry. Yeah, the first one, because it helps to move from low to high.
Yeah, that's correct. The answer is correct, absolutely. That when you're introducing comparisons, don't start off with comparing just 7 and 6, or say 2 and 1. You're trying to help a child visualize that comparison means something is big and something is small. So driving a new concept home is always easier when you're able to show a very large magnitude of difference there. So if you start with 7 and 2, or 8 and 3, it's much easier for a child to understand something is really big and something is small. The magnitude of difference is just one. Sometimes a child might make an error in counting, or just the way spatially it's arranged, it's not very clear in their head. So when you're introducing a concept, start with something that's big in terms of comparisons, and then move on. So even when you're giving them worksheets to do, when you're preparing your first set of comparison worksheets, which is bigger than what, you introduce a crocodile's mouth, bigger, greater than, less than, small, symbol. Start giving them the initial set of worksheets where they compare 7 and 1, or like I said, 9 and 3. Not the first set of worksheets. If you were to give 6 and 5, it just might be a little difficult. I'm still talking about worksheets, not numerical. Even worksheets where you've drawn things visually, where they can count. Even there, please start with large differences and then jump into the smaller differences. That's the increasing level of complexity that children will find it easier to understand. Otherwise, this misconception might set in where, or more importantly, it's not even a misconception, it's a phobia that can set in. I don't understand what is bigger than and what is smaller than, when the difference is very small at the point of introducing the topic. So that definitely reduces the fear of understanding topics like comparisons. Now we move to a slightly higher level of complexity of understanding counting itself. And it's, to my head, it's a very, very important activity which can help lay a strong foundation for all the four numerical operations, whether it's addition, subtraction, multiplication, or division. This is called subitizing. Subitizing, the idea of subitizing or the activity helps a child recognize a certain count of a certain number of objects arranged very fast. And you need to be able to build this ability before you can move them on to abstract concepts of addition, for instance. So here I have a question for all of you. I'll just describe what this activity is that you can do. And I have a question for all of you at the end of this. In this activity, what you do is you take cards. You can hand prepare them yourself if you want. I'm not sure if these are easily available. It's pretty simple. You can just take a piece of paper and you can just draw a bunch of dots on it. And you show a card like this, just one card with a certain number of dots to the child. And give them under 5 seconds, ideally. Ask them to recognize the number of dots they see. You count 1, 2, 3, 4, 5, and you take away the count. And then you do this, sort of repetitively with different values. So you can do 1, 2, 3, 4, 5, up to 9. That's all. Now these are examples. Now if you're doing it online, how do you teach? How do you execute an activity like this? You could again just pre-prepare your PPTs, or if you're using a virtual board like this, you could just draw those on the virtual board. So if it's a PPT, you can just choose a certain slide, show it for 5 seconds, and then move on to a blank slide. So, and you give the child roughly about 5, 6, 7, 8 seconds. They should be able to recognize how many there are, right up to the number 9 in the ideal world, at least up to the number of 5. But 9 is the ideal. You want to get a child to recognize how many there are. As an adult, even you can just try out this exercise right now. Take 30 seconds and see how many cards are you able to identify the different cards. And then I'll ask you one question. Okay, now here I hope you all have just looked at the cards and tried to count and said this one is 3, this one is 4, this one is 5, and so on. My question to you is, look at this card which has 6 dots, right? And look at the first one which has 3 dots. Of course, my question is relevant across all. What other concept do you think a child understands when they look at a card where 6 dots are arranged like this here and 3 dots are arranged like this here? It's another concept that a child learns. Are you able to guess what that concept is? Please write in your answers on the chat.
Yes, a lot of answers. The first answer is bigger to smaller, smaller to bigger.
Okay.
Ascending and descending. Grouping.
Okay.
Pattern recognition memory game.
Right.
Sequencing and symmetry.
Very correct.
Even and odd numbers concept.
Okay.
Subitizing numbers help children see how numbers are made of and help children develop pattern.
Yeah, very correct. Very correct.
Then students will learn counting in different ways, like from left to right and up to down.
Absolutely.
And comparing through visualizing, concept of multiplication can be understood.
Right.
And I think someone is complimenting you. Neat work.
No, it's taken from somebody else, sir. I can't take any compliment for it, but yes, I should take it.
Yes, and odd and even.
Okay, great. Fantastic. In fact, almost all the answers were bang on. That this pattern recognition, this your ability to visualize sound. Just to paraphrase or rephrase some of your answers and to sort of hit the nail on the head. Summarizing helps. We'll just look at the first example and we'll see. The number 3, the whole of 3 can have many parts. The part whole concept is something that we help a child through pattern recognition. So if you look at this, the child can see the number 3 can have 2 and 1. So that's one way to arrange 3. If you were to make another card for 3, you could just draw, say, 3 circles like this on the card, where they are, say, equally spaced. I haven't drawn it equally. So it can just be 1, 1, 1. So 1 and 1 and 1 make 3. 2 and 1 also make 3. So the part whole concept is very clear. Look at this one which has 5. Here the part whole they look at is 3 and 2. So 3 and 2 also make 5. So before even we get into addition, the idea that a whole number, a large value can be broken into multiple parts is something that they unconsciously develop through this activity. And I definitely recommend that teachers do this. And again, this is do this frequently. Once you finish those first 5, strategies we looked at, to sort of cover those misconceptions. Do this several times over. It will really help develop the mental ability to absorb a pattern and retain that number value. It will help them understand, lay a good foundation when you're teaching addition. They'll become faster in visually, even in counting abstract numbers, like say 3 and 7 make 10. That concept they'll be able to absorb very fast through this activity. And it's very easy to do both online. In fact, I think it's much easier to do it online, than probably in a class. Because in a class, you have to sit with each child to do this. And online, you're not physically sitting. You can just call out this child, look at this PPT, quickly tell me. Another child, and so on and so forth. Or if you have to keep the attention of all the children at the same time, you can just tell everybody, here's the card, 5 seconds, time up, give me your answers. And then, you get all of those answers. So that way you collectively maintain the focus and attention of the entire class. It's a very valuable activity to be repeated many times. Doing it once or twice will not help. It has to be done many, many times. So yeah, you're making the big leap for a child from the number counting to the part whole concept. Now we move on to the counting of 99. Here I just have only one major point to drive home about how to teach numbers up to 99. Traditionally, schools would do 1 to 9. You learn, show them how to write those 1, 2, 3, 4, 5, 6, 7, 8, 9 is simple. And usually you move after 9 to 10, 11, 12, and the teens. Instead, anyway, I'll tell you the instead part later. Let's first look at what materials you need to use. When you're teaching place values, the use of kinesthetic material, I cannot understate. I cannot overstate it. It is very, 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 very essential that children work with materials to understand place values, especially for the first time when they're making the crossover from 9 to 10. That point you need to drive home that the moment quantity exceeds 9, start bundling them into groups of 10. So if you're doing this in a classroom setting, one of the easiest material you can get in the market is straws. You could use, or you could use those ice cream sticks, which can be, you could just tie a rubber band around it and make them into groups of 10. So these are some of the easiest materials that are available. In case you're not able to get these, you can just use like printed paper with those circles with threads with 10 dots on each, grouped into 10. So the crossover child has to be taught. The activity is the moment a child crosses 9, tell the child that the moment it is 10, you put all of those together and put it into one bundle. They have to learn to physically collect all the straws and like tie it up into one bundle, or ice cream sticks, or it could be sketch pens or whatever it is that you're using, or if you're using blocks, you could use those blocks. They work beautifully. And then they have to put it into one bundle. And then don't just go with 10 and 11. Start with large numbers. You can do 63 to a child. The concept that they are trying to understand and grasp, or that we are trying to help them understand, is that the moment it is more than 9, you have to put 2 digits there. And the first digit is a set of 10s, and the second digit is a set of 1s. They already know up to 9. So they can collect 6 bundles of straws and they say, oh, I have 6 bundles, so it's 16. So I write it as 6. And then I take 3 more, and then that's 63. And so they have to learn with large numbers to understand that my first digit represents the 6 big bundles of 10, and the second digit represents just those 3 little straws of 3. So when they have to physically pick up these objects and work with bundles of 10 and individual ones to clearly understand what is the 10's place value and what is the 1's place value. If we expect our children to, master the decimal number system place value without kinesthetics and just blackboard writing or writing in a notebook, it is inevitable that they will carry a lot of misconceptions, and it will lead to more problems when they go to the hundredth and the thousandth and the 10,000th place value. So the 10th place value itself make them understand that 2-digit numbers are not symbols. 2-digit number 10, all along the child is learned. See, this is a symbol. 2 is a symbol. 3 is a symbol. 5 is a symbol. There is nothing. I can't explain why 7 is written as 7. It is just a symbol. It is the only way I can notate and show. But the number 75 is not a symbol. The number 75 represents a certain place value system. So you have to make help the child understand that, oh, so far till 9 it was a symbol, but the moment it crosses over from 10, it's not a symbol. You cannot explain this with words to a 4, 5, 6-year-old child. The only way to do this is kinesthetic activity where they have to pick bundles of straw, break them, and then write in the respective places. So I'm just going to move on to the next here. This is a very important activity. Like I said, I can't overstate it. It's very, very important. Sorry, just a second. Yeah. So now moving on to addition. How do you introduce addition? It's a normal activity that I think most of you already are familiar with. But I have a question for everybody at the end of the second slide. This one and the next. In this is simple. You just write write a number on the board. Let's say 7, and you tell the whole class together. Let's count onwards. Let's count 4 onwards from 7. So they all start counting 8, 9, 10, and 11. And then you write 11 on the board. And it's a group activity. It's just auditory. There is no kinesthetic. There are no objects. By now, they understand what counting is. They know what place value is. They know what 7 and 4 and 11 mean. So all of that we've done. Now we move on to this. And then we move on to you take an object. Like you could take a bunch of objects with you and you have to show them how you're putting these objects together. Like say if you have some leaves and you say I have one leaf, I have another leaf, I'm putting them together, and then I make 2 leaves, right? So, and this is what I write on the screen or on your blackboard, or if you're doing it online on your interactive whiteboard. What's the difference between the way you're writing things here, 7, 4, 11, and the way you've written it over here? What do you think you're helping the child learn? What concept do you think the child is learning? Just and the way these 2 numbers are written. I invite your comments. If you could write it in the chat box.
So I think there is one answer here on Zoom that's to help arrange the numbers. Okay, symbols introduced to the child here. They've been introduced to the child here.
That's correct.
Vertical and horizontal addition.
Yeah, true. That's true. I think, both those answers, those 2 were the important points. Here we were doing it vertically, and here we're doing, and we introduced the concept of plus and equality, the symbols of addition. You're introducing it where you did it without any addition. No addition, no equality. Here you're doing the addition and the equality, and you're saying you can do it vertically or you can do it horizontally. You're introducing those 2 concepts. This is an activity which I'm just going to quickly run over. It's very simple, where you could just give some number cards to children, ask them to pick up in random 2 number cards and a kinesthetic. They have to have an object where they can count, put them together, and then write the answer. Not doing just mentally counting onwards. Please definitely ensure there's a kinesthetic involved first before they move on to the abstract counting. Doing addition, direct abstract will mean you'll have a lot of other problems as they come. Now we'll quickly come into the common errors in addition. So I'll give all of you about 10 seconds. Just take a look. I'm sure all of you come across these 4 kinds of errors. Now we'll move on to understanding how we need to address each one of these 4 errors. Why do these errors, why do these misconceptions occur, and how we can address them? In the ideal world, I would recommend, if you're teaching addition 2-digit or 3-digit, to avoid misconceptions, please adopt these 3 methods that we're talking about. If you typically adopt these 3 methods, you will not see children making any of these 4 kinds of errors in your answer papers. The number 1 is this error over here. The reason why the child has not understood this is he doesn't know that 8 plus 4 is 12 and 3 and 1 is 4. That's correct. His addition is perfect. He's not made any mistake in his addition. The only problem, the concept is not clear, is in each place value, I have to write only 1 digit. I can't have 12 units. The moment I have 12 units, I need to break it and break it into tens and ones and move the tens together. That is not very clear, that I cannot accommodate 2 digits in 1 place value. So using the place value house is a very common teaching method. You just take a chart like this, and you draw a house, and you draw a hundreds and a tens and a ones, and you tell them very clearly in each box that you see over here, you can only write one digit in each place. You cannot write more than one digit in each place. So that's the, if you start off teaching addition with the place value house, they get into the understanding that in each box, I can only write one digit. So if I have 12, you can't write 12 there. Then the child will be forced to think, okay, now where do I put that one? What am I supposed to do with that one? And we'll move on to the next activity, which should sort of help them understand. I'm sorry. In this, if you see the error over here is the grouping of the wrong place value with the wrong. So there's 200s here and the 310 which have been grouped together. Now this again, I've added 2 and 3, 5, 4 and 3, 7, 5 and 0, 5. So everything is perfect over here to see. But I've just grouped it incorrectly. So again, using a slightly different form of the place value chart usually helps that they write, okay, this is 200. So they use the expanded form, and then there is the 40 over here, and then they write the 5 over here. And they come to the 33. In the expanded form, they should understand by another 30 and 3. So they put the 30 in the tens, the blue color box there, and the 3 in the ones place, and the yellow color house there. And now it's very clear, okay, I only compare and add those that are in the similar color houses. So I don't take the blue color 10s and the red color 100s and add them up. So that concept is very clear again if you are able to use the chart. So again, if you're doing this, you're teaching this concept online, very easy, just recreate your slides with this picture and just, you can write on top of it when you're teaching. It's very, very clear. If you're doing it in a classroom, you could just give them printed worksheets with these pictures beforehand. Now here, if you've taught a child only up to a number 99, you've never taught a child what happens if the number exceeds 100. Or maybe the child wasn't paying attention when you're teaching. It could be anything. So the problem here is the child doesn't know 8 and 1 is 9, 5 and 7 is 12. I write up to 2. And I also know I cannot combine two different place values in the same place. But I don't know what to do with the extra 1. So that's the problem for this child. So then you have to introduce our decimal number system that every additional value is to the 1 power higher of 10. Maybe that's a little difficult to say, 10 power 1, 10 power 2, 10 power 3. You can't say that to a grade 1 or 2 child. So you could just sort of show them in this kind of an arrangement using Lego bricks to show you can just move on to the left. So if I have 1 and then I have 10 and then I have 100 and then I have 1,000, and you could build one more Lego brick and say it's still 10,000, and they will automatically write with a sketch pen there it is 10,000. So this misconception, if your child has this misconception, one or two times of just helping them visualize with these Lego bricks, they'll be very clear. Every additional place value just moves further to the left to show the increasing magnitude. This usually works very beautifully. This doesn't take much time. Yeah, and now we come to the common errors that are there in subtraction. I'm jumping over the part where you're introducing subtraction. So introducing subtraction, I think again, I can't overstate. Kinesthetically, please use objects to take away from one to another to show that subtraction is a reduction in the quantity. So you're reducing something, you're taking something away. That's the concept you want to help them understand. Very similarly done like what you did for addition, you could do it in the blackboard and you've got to use objects. Now I'm moving on to the subtraction with borrow. A lot of kids. Subtraction with borrow is probably one of the toughest topics. Biggest math phobia causing problem for children in grade 1 and 2. I've seen kids pulling their hair apart. It's so difficult, man. What am I striking out? Why am I striking out? Which one do I borrow? What do I do? Then if there's a 0, they'll forget what to do. It's very confusing. So I can completely relate to a child who's, because the subtraction with borrow, by the way, is one of the more complex activities that even cognitive psychologists say. So if a child has trouble, we have to really empathize with the child. So again, I'm going to give you about 30 seconds. Take a look at the slide. There are 4 common kinds of misconceptions that all children go I have a question for all of you at the end of the second. Next slide, not this one. And I'm hoping that all of you do come across these kind of misconceptions commonly in your classrooms also. If you're teaching grades, I think 2 is when probably subtraction and borrow is introduced. So move on to what do we do if children face these issues, or what do I do to avoid my children facing these issues in both ways? Okay, first one is this. This error happens 5, 7, and 2. We always teach our children 8 minus 6 is 2. In all our worksheets that you make for your children, you will definitely give them 8 minus 6 is equal to 2. And I bet no teacher in grade 2 will write 6 minus 8 is equal to what? We never ask our children that because we have not introduced the concept of negative numbers. But it is important for them to be introduced to the non-example now. You don't have to say what 6 minus 8 is equal to, that it is minus 2. No, you simply have to say 6 minus 8 is not 2. That non-example, when you're teaching an example 8 minus 6 is 2, also teach them at the same time the non-example that 6 minus 8 is not equal to 2. You cannot take 8 out of 6. So it is not, the answer is not equal to 2. You don't have to get into any further elaboration, but that non-example is very, 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 very important. If we did this, when the child comes across a 2-digit number, we should do this when we teach single-digit subtraction itself. When you're asking them verbally or in the written form, ask them enough about non-examples. When they go into the 2-digit subtraction, they will know that 5 minus 7 is not 2. Then they are forced to think, oh, now what do I do? I know that 5 minus 7 is not 2. And then hopefully they understand what the concept of borrow is. But what I'm trying to say is, even after you've taught borrow, you will still see children making this mistake. And the reason that mistake comes is because they did not understand that non-example clearly in their head. When you're teaching an example, this non-example of 6 minus 8 is not 2 helps a lot when they have to do the subtraction with borrow. One more example of non-example. We almost always say that when you're taking 0 from a number, the value doesn't change. 7 minus 0 is 7, 10 minus 0 is 10, 20 minus 0 is 20, 5 minus 0 is 5. We don't teach the non-example that 0 minus 5 is not 5. 0 minus 12 is not 12. That non-example should also be ingrained in their head for both the 0 and any value that is lesser, so that when they come across a question which involves borrow, they don't take comfort. I'll just reverse the order and do 6 minus 0, and I have to do 0 minus 6. That sequencing of which number has to be subtracted with what can be very easily and very well taught if we do a lot of non-examples also in the class. The word non-example means anything that is not an example, that will not fit into the definition of what you're trying to teach. So these two non-examples, please definitely ensure. This helps averting two major misconceptions that children carry in their heads. The third, which is the idea of borrow. So whenever you're teaching subtraction with borrow, again, it has to come with kinesthetic materials. Here I've just shown you the example of straws. So take bundles of straws, put many bundles of 10 straws, put a rubber band and arrange them. They have to work with materials. So if you're doing this again online, how do I ensure my children work with materials? Give your parents maybe a week or 10 days time and tell them to buy 100 straws from the market, bundle them into sets of 10 and keep them ready, and you demonstrate it if you're doing it through a video or something. And you tell them what 72 minus 34 is. You make them arrange them into bundles of 7 tens and 2 ones, and then 3 tens and 4 ones, and then they've got to take the units alone away. If you're doing this for the first time, don't do it directly with subtraction with borrow. Do it with subtraction without borrow. So first they have to know what the activity is. So actually, the precursor is they should first arrange straws. If you're giving them 72, they should know what 72 is. So they have to get 7 sets of 10 straws and 2 separate straws. Then you tell them what subtraction is. So you do it without the borrow. So 72 minus maybe 20. They just take 2 bundles of 10 straws out and then they write 52. Then you move on to the borrow. Take it step by step. Don't make the leap directly to borrow if you're using an object for the first time that the children do. Ice cream sticks, straws are the easiest available, I think, almost everywhere. And it has to be easy for a child to use. So you can't get pebbles and stones for these kind of things, and you're definitely not going to get 100 mangoes. They probably will be eaten away anyway during the class. So use objects that are easy for a child to use, and one where they can put it in a rubber band or something, break it into parts, and then sort of take it over. So I'm coming back to I said I have a question for all of you. In when you're doing when you're teaching them this and this, these 3 kind of activities, what do you think is another additional concept or a misconception that you're probably helping the child avoid? What new concept in subtraction do you think that you're doing? Or what are the qualities that you're bringing into the child in all of these 3 teaching strategies? You could just type in your answers on the chat box.
So looking for answers.
I think we've also overshot our time a little bit.
Yes.
Oh.
We've done that, but yes. Looking for answers. Yes, concept will be clear to the children. That's what Ms. Ramya Nair reckons. And looking for answers on Facebook simultaneously. The clear picture of borrowing. Reasoning will happen. Observation and students would be focused. Place value concepts with subtraction could be understood. Concept is clear. Place values, so it's hovering around both.
Okay.
Yes.
One more, but you're absolutely right. That's what you're hoping. That, borrowing.
The child. The child understands borrowing and straight subtraction using place value, and there is no confusion. In fact.
Okay. True. So I'm just going to conclude with this one statement, and then if you have the time, we can open it up for Q&A. The only statement is always when we teach our children, especially if you look at the first 2 examples, 8 minus 6 2 and 0, 6 minus 8 2, and 6 minus 0 6 and 0 minus 6 is not 0. 6 minus 8 is not 2. So doing these. When we teach children addition or subtraction, when we teach them with non-examples, you're forcing a child to be more alert than if you give them 10 minus 7 minus 3, 4 minus 2. They just get into a routine. Okay, I have got to pick up 4 objects, take away 2, and then write whatever is remaining in my notebook. I take 10, I take away 3, and then my remaining is 7. The alertness, they just fall into the stupor. Oh, okay, this is what I'm supposed to do over and over again. The alertness to say, oh, okay, here is 3 minus 4. What am I supposed to do? I've not taken 3. I can't take away 4. What should I do? So when you just let a child slide into a certain pattern of just repeating a certain thing over and over, and then mix it up with something that forces them to be more alert, helps them understand a concept way better than just giving them a worksheet which is a series of examples. Forcing children to be more alert is always a good idea when you're doing any kind of a conceptual teaching. Non-examples is an easy trick to ensure that kids stay alert. So yes, with that I wrap up my session, and I'm really hoping that your takeaway is that you've got a lot of different teaching strategies and methods like the children who made multiple different thoughts and came up with a lot of answers, a lot of thoughts. So, which helps them overcome many different kinds of misconceptions and errors in the process of making thoughts. Math is no different. Learning any subject is no different. Any topic. With that, I wrap up my side of the presentation. If we have the time, we can take questions from you.
Sangeeta, so we're just waiting for questions. However, I think there are a lot of praises, uh, a lot of compliments. Thanks a lot, Sangeeta. Maths made easy is what Tarik says. Wonderful session. Enjoyed a lot, ma'am. Uh, so we are waiting for questions. However, any questions, please?
You
Not
have it.
not compliments, but questions. So, uh, okay. I think there is a question. No. Uh, you just, I think, through your session, cleared all the questions.
Okay, I
Uh,
hope that is true.
I reckon, because more than questions, a lot of compliments. They're just flooding on both Facebook as well as Zoom. So, uh, and also we've got about 400 strong audience across both the platforms from across the country.
Great.
Okay, so Vidya has asked a question. I think I just missed it. I'll read out that to you, Sangeeta. How do you suggest borrowing subtraction is dealt within lower grades for specially abled students?
So I'm not an expert in dealing with all kinds of special abilities that children come with. But typically, anything that involves all the sensorial skills is a solution for children with any kinds of abilities or differences in abilities. So, if you're, I'm assuming therefore that you're anyway going ahead and using the kinesthetic idea that we spoke about, where you help them first touch, feel, bundle the objects. Taking objects, working and touching and feeling. Sensorial skills are very, very, very important. So if the child has been given enough of the touching and feeling, then sometimes I don't know, there are again, I'm not an expert, but there are some research ideas around using say music, which means you help a child hear certain number of sounds, and you help a child hear a slightly different number of sounds, maybe a smaller number of sounds, which is sound related, which means so far all the activities we were dealing with were only visual and touch. So if maybe the child is still unable to understand visual and touch, maybe sometimes just giving them an auditory input, which means you can't go into very large numbers, that's hard. Like say you're doing 12 claps or 12 dongs of a pendulum and then a smaller number, and they listen to the differences, and then they slowly understand, okay, one was 12, one only had 5, so how many lesser were those? So that's a different way of, again, teaching subtraction, which is to say the difference. And then when but finally when it comes to say breaking, and which is, you have to break sets of 10, which is what borrow involves. It has to come back to the visual and the touch sensorial. Child is still struggling with it. It's probably used to one of two reasons. You're introducing it to a child, regardless of whether the child is specially able or the child is perfectly normal. It is not uncommon. I have seen many parents and educators, very well-intentioned people, who introduce subtraction with borrow at an age where the child is not ready to absorb that concept. So if you're forcing a child to learn it ahead of when the child's brain is ready to absorb the idea of breaking a bundle of straw, the child is not going to learn. So no matter how well intentioned and no matter how many bundles of straw you buy, it will not work. So it could also be because of the age inappropriateness for the child. That is one common reason, or the other is enough time for practice with that has not been given, which is what I was hoping to cover. I mean, I rushed through this. This is a very famous, I bring this forgetting curve, which is if you teach any concept using a certain strategy. Let's say we are all talking about addition with carry or subtraction with borrow. If you do it once, it is never going to work. So this shows that on the day you teach, the child might remember 100%. 20 minutes later, the child will only know 60%. 60 minutes later, 1 hour later, the child will only remember around 40%. And say 30 days later, if you have a unit test, only 20% chance the child will remember what you said. And there's always a spaced repetition, so you repeat it, so you got to go do it, to repeat the same activity 1 hour, 1 day later, and the same 1 week later, and the same at least once more within a month later. This is the ideal spaced repetition curve that is recommended for learning anything, whether you're learning a piano, whether you're learning subtraction with borrow. This is true. So yeah, specially able, in other words, use more sensorial input from the
Activities.
child, activities, ensure it is appropriate to the child's age, and ensure it's repeated many times over to become practice.
Okay, I think that's all the questions that we've got. In fact, we've got a few suggestions perhaps for the next session also. I
Sure,
think we'll pass that on to you.
sure.
So, on behalf of Colin's Learning, we would like to thank Sangeetha ma'am for her wonderful session. She's taken her time off, precious time off, to be with us and uh, allow us understand mathematics, to set the foundations for all the students across this nation. Because what happens is, when the foundations are not set for mathematics, then students believe the subject is way off their tangent, isn't it? So I think these ideas and thoughts and these activities will allow all the teachers to allow the students a wonderful foundation. With that note, perhaps we could sign off. And thank you so much, and have a wonderful day and a week ahead.
Thanks, all of you.